I just got a package from Universal Solder. He emailed me a while ago mentioning that he had some new product, a new line of stuff that he was releasing, and would I be interested in taking a look at it? And I said, of course. So Canaduino is the branding that Universal Solder uses for their own kits and their own products, not the stuff that they're reselling, which they do a little bit of too, but all this is their own designs. If you've been around the channel for a while, you've heard me talking about Universal Solder before. They are one of the very few Canadian manufacturers of electronic modules and kits and hobbies and stuff like that anymore. So let's see what this massive bounty is. I didn't expect him to send this much stuff, quite honestly. This looks like he's given me one of just about the entire line of these products. So I'll probably just start unbagging these things and we'll take a look at them. And I think this base plate, this large base plate, is probably a good place to start. While it is designed to be a beginner-friendly system, there is a little bit of soldering to be done, but it's just a matter of putting the headers on. Nothing too difficult. So I think I will quickly solder up this large baseboard, which has room for 16 modules on it. And all that the base plate is doing, other than holding the modules physically, is running the power ground and I2C signals, the SCL and SDA, around to all of the different modules. And the point of that is to make it very easy to quickly experiment and prototype and whatnot, and you don't end up with jumper wires flying all over the place like so often happens. And you've seen enough of my projects that you've probably seen something that's got a ton of jumper wires all over the place and all messy and annoying the OCD people. So this will get around that. Just like every kit that I've ever got from Universal Solder, this one goes together very well. It's a quality board. It solders easily. Nice, classy black solder mask on it. We're off to a good start. So each of the base plates comes with its own headers and its own screws and standoffs and whatnot. I'm just going to leave the standoffs off for a minute here. Let's start taking a look at the modules. The first one that I grabbed off the pile is this DS3231, which I think is a real-time clock module. And this one comes preloaded even with a CR1220 cell. Batteries included. That's cool. On the back of it, it has the chip. It has a couple of ports, so you can use these standalone. You don't need to use these modules with the backboard, and it does come with cables if you want to use it that way, but you don't have to. And how it's sort of intended to be used is with header pins and plugged into the baseboard. Yes, I haven't soldered it in yet, but it's plugged into the baseboard, and that's where these standoffs come in. So had I already pre-mounted them, you just screw them on there if you want to, or you can just plug them in and let them stand there. So I guess I'm going to start soldering up a few of these and probably putting the standoffs on there to demonstrate it. I think that's the best course of action. Or maybe I should just open up all of these guys and see what we've got. Yeah, let's do that. The next one is called a keypad. So this is a 16-button keypad, and it's even labeled 0 through 9 and A through F, so good for hexadecimal entry. And as before, it has the 4-pin header on there that matches the baseboard, and a couple of jumpers, all I2C. And oh, this one, in addition to the chip doing the keyboard matrix, allows you to select which I2C address from 3 possibilities, and that allows you to avoid address conflicts. Clever. No jumpers involved, just a switch. Very nice. I guess before I get too carried away on this, I should talk a little bit about microcontrollers that would control these. And of course you can just use any microcontroller and run the I2C lines into it, or how it's really intended to be set up is to be used with this little JAL module and the Seeed Studio ESP32C6. That is how the examples are all tested, and that is how I'm going to be using it. So that guy just mounts onto there with header pins, which are in a different bag. And then once you solder the header on, that can go literally anywhere on the board and provide I2C across to all of the different modules. Next in, we have a 7-segment LED module, which is 6 digits of 7 segments, and same arrangement on the back. And this module is the first of them that we've pulled out that is a double width module, but the system is again designed to handle single width, double width, and I think there are some larger modules in here too. Matter of fact, here is one here. This is the large LCD module, LCD 164. And this one is designed to take up a 2x2 footprint on the baseboard like that. I'm going to start running out of room on the baseboard before I get all of these things opened up. What is next? We got an ADS1115, which, if I remember correctly, is an analog to digital board, which is why it has this screw terminal on here. Of course, it's labeled on the back. We have ground and 4 inputs, and then again, we have the I2C selector so that we don't have address conflicts. Which also means if you wanted to, you could run 3 of these modules and just give them all independent addresses, and you could have a dozen analog to digital inputs. What's next? Let's see, MCP 23017. So this is a GPIO expander. It looks like it has 16 inputs or GPIO, and again a potential 3 different addresses. I've still got a whole bunch more boards to go through. What is this one? It is a MUX S, so presumably there's also a MUX L, the larger version. You notice this one has 4 breakouts on it, and again an address selector switch. But what this chip does is to allow you to use the same I2C address on multiple devices and break it out using the connectors. So in the software, you address this thing and then give it sub-addresses to go out to the other ones. There is demo software for a lot of these, and I think I'll show you a little bit of them later, but not all of them, because that's going to make for a 2-hour-long video, and I don't want to do that to you. Next one in, the AT328. This one is another microcontroller. If you don't want to use the ESP32C6 down there, this one is another option. Yes, it is the Atmel ATmega 328P, the central chip behind the original Arduino Unos. And it has on it a USB connector, so you can program it just like any other Arduino. Reset button there. Oh, do we have a blinky LED on this side? Yes, I think we do. The USB to serial chip. A couple more I2C breakouts there, and the I2C breakout to go onto our baseboard here. Now, I don't know that you'd want to use both this one and that one together. I suppose you could, but and you'd probably also want to put this over there if you're doing it. I'm just going to park it here for now. And it comes with screw terminals for all of the GPIO that it brings with it. Still plenty to go. Next one is a BME 280, which is a temperature module. And again, we have a couple of choices for I2C address. Notice how he's got the actual module sitting on a little island there so that the temperature of everything else surrounding it isn't impacting it as much. Actually, that's a temperature and barometric pressure module. You see the little hole there for it to sense the pressure? Okay, that's neat. The more I look at this, the more it is a fairly complete getting into microcontroller tinkering kind of a project, or kind of a system. What is this next one? VEML 3328. According to the website, this is a light and color sensor. Using that itty bitty sensor right there. Even the modules that don't have a switchable address on them have the I2C address screen printed right onto the board. That is a nice touch. Next is this little SQG module, which is a breakout to the Stemma plug or the Grove plug. And like all the others, it has this style, which are called a Quick. I think that's how you pronounce it. And between these three connector types, you should be able to get to just about any of the I2C modules that have a connectorized system from various different brands. What is this one? Indicai MV. This is one of the few modules that doesn't actually use the I2C. This is just a 10-channel indicator module. It has high impedance inputs, so you can just visualize what's going on various different things that you connect to the screw terminal on the side of the board. And next, that's a base plate. That's a base plate. What is this one? Says pull-up. This is essentially a bus terminator for the I2C bus, which isn't always necessary, but it is one of those good practice things. And the more modules that you get onto the bus, the more likely it is that you will need that just for extra stability. And that's not just to do with this particular system, that is anything that uses I2C. So we're starting to get down to the last of the main modules, and then, like I said, we have the base plates, and we have a few other miscellaneous bits and pieces that he's sent along. This one is the DC to DC module. It is, as you might suspect, a DC to DC converter to bring in, let's see, what does it say on the bottom here? That will allow you to take between 6 and 15 volts in and give you a 3 volt and a 5 volt output. Although, of course, only the 3.3 volts goes down to the baseboard and to the rest of the modules, because this entire system is based on 3.3 volt logic. But the 5 volts is available on screw terminals. So in addition to the active modules in this system, there are also just perf boards that you can add on, and they match the same pinout as everything else. They've got the I2C and power marked on the sides where they can come in. If you plug them into the baseboards, those are handy just for making your own modules that are compatible with the system. And there are these filler boards, which are just blanks in case, unlike me, you've got the board partially filled and you just want to make it look nice and neat. You can put on these nice little black and gold trimmed boards just to fill empty spaces. And what else did he send me? He sent me an extra pack of hardware. Wow. That's a lot of stuff, and that isn't even everything that's in the system. He has more on the website that are set to be released soon, and there are several more items that he didn't send me. I intentionally requested that he only send me some of them, because there's no way that I would be able to show off the entire system. This is already getting a pretty long video, but there is the medium-sized baseboard over there. Here is the small one, and of course they come with their own hardware packs and stuff too. So you can do various different size projects. You can have multiple projects on the go at once. I am going to take a bit of time off camera and solder header pins onto some of these and put the standoffs on so that I can mount it up properly. And I will demonstrate a couple of these modules. I'm not going to demonstrate them all, because again, that would take all day. But yeah, I think I will do a few of these just to quickly demonstrate them. And while I'm doing that soldering, you guys go over and take a look at the website. Hang on here. So far, there's 39 items that he's got in this line, including the cabling kits and the hardware and everything else. A lot of these are the ones that we saw. There's an external EEPROM module that we haven't seen yet. There is an accelerometer module that I didn't get. What else? There is an LED matrix. That's pretty cool. There's some other sizes of baseboards. There's a current sensor module. There's UARTs. There is other power injection modules. There are some other environmental sensors. There's instead of using the breakout that came for the ESP, there is also this one that has screw terminals as well. There is an atomic clock module, and as he said in the description page, he has over 60 modules planned. So this is just the initial launch of this thing. I'm interested to see what it looks like when it's all rolled out. But in the meantime, let's get back and play with a few of these. All right, much soldering has occurred, and let us play with this a little bit. So we got the ESP32 in position 1, and it really doesn't matter what position they are because it's all in parallel. I've got the temperature sensor, or temperature and humidity and barometric pressure sensor down here in slot 16. So let us just power this on and throw some examples code at it and see what happens. Plug the USB-C into this guy. We've got a light over there. Oh, looks like it came from the factory with a blink sketch on it. Cool, that tells me it's alive, which I guess shouldn't be a surprise. Let's jump over to the website and grab the example code, which is down here. It downloads a zip file, which contains that folder and a test Arduino type script. So I'll drop that folder into my Arduino folder. There is the sketch. You can download it and read it if you'd like. I'm not going to bother. And there is the printout from it. It is showing the temperature, the relative humidity, and the barometric pressure in my workshop at this time. Let's grab another module and throw that on too. We'll plug in the clock module anywhere at random, really. It doesn't matter. I'll put it there. Oh, yeah. You may have noticed that I've got some of the pillars on here with the female thread up and some of them with the male thread up. I started putting them together with the male thread up thinking that this would be a good idea, but then I noticed on the bottom, if I have the screw heads there, then we may be crashing on the pins. So I decided to put the spacers on the bottom, and when I need to lock something down, I'll just use a little screw. Although for this one, I don't think I'll concern myself with it. Also, because it's I2C, I should be able to have multiple things on the bus as long as they're not conflicting addresses, and these ones aren't. That one is 6.8, this one is 7.6 or 7.7, currently 7.6. So I'm just going to leave that there. I'll put the software for this on here, and we'll see what happens. Now here's the code for the real-time clock module. I think I'm going to just use it exactly as it comes out of the box, and we'll see what happens. I may need to add some libraries. We'll see. Compiling. Okay, that's done. Let's see what's in the serial monitor. Date and time. Is today, in fact, November 13th that I'm recording this? Yes, it is. Is it 20:33 o'clock? Yes, it is. Cool. So it looks like when I connected and loaded the software, it set the clock on the thing to match my computer. So that's pretty cool, and it obviously worked. Otherwise, there are some checks and balances up here. If it hadn't found it, it would have complained. So that's kind of neat, and I could put any module I feel like on there, anywhere I want. I got a little bit lazy and I didn't put all the standoffs in here. One of the reasons why is that there are a few modules that the standoff may collide with the underside of another board, so I've left some off. Some of them are a little busy on the back. But regardless, I can just throw those on as I need them whenever I feel like it, and I can plonk any of these guys in there, and that is all good. And I also decided to load up this second baseboard, and I've got another one over there too, with the AT328, otherwise known as an Arduino Uno. And this chip actually is preloaded with the Uno bootloader, so you can pretend it's just a normal Uno when you're loading it, which is pretty cool. And the other thing to remember about it is that it's a 3.3 device, 3.3 volt device, like all of these devices are here, as opposed to the usual Arduino, which is 5 volt tolerant. So anyways, let's play with this one just a little bit. And the demo sketches that he provided for most of these modules were written targeting this ESP32. Oh, this one's got a blink sketch in it too. Cool. But these are all fairly standard items, and if you just download the library for the chip that's the core on it, like the BME280 or whatever, it should just work. What am I going to do with this? I am going to add this board, which is the indicator board, and it doesn't use the I2C. Let me just power that off for a second. It just takes the power and ground, and it is designed, as I mentioned before, to just be used to display different values that you have going on, just so you know what's going on. I'm just going to connect it to D13, which is that blinking light there, and we'll plug it back in, and that should blink right along with it. So that would be handy if you're using the GPIOs on there and you just want to check and see if you got the expected value coming out of them. These are high impedance inputs, so they're not going to load your circuit down any. So that's kind of handy. Now you can, as I mentioned, plug any of these modules in over here too. Of course you could. Why couldn't you? But something else that occurred to me is that because this has these quick connectors on it, I should be able to come off there, which should just be paralleling the I2C bus, and go into the quick connector on any module on this board. Let's use this one, for example. And then you can expand your network across both boards. I'm just going to load up the I2C scanner, just this very standard, very basic I2C scanning sketch, and it should be able to see everything that's on both of the boards. And there we have 4 I2C addresses detected: 233E, 68, and 76. 23 is that one, 76 is that one, 68 is that one, and the keypad I think has a switch on it, doesn't it? Why doesn't it show me what its address is? Well, I guess we know what its address is. Or I could look at the switch on the back, and it is indeed set to 3E. Cool. So that's just a really, really quick look at a couple of these things. The whole ecosystem is pretty intriguing, and you saw how fast I was able to reconfigure it to do different things when I was experimenting. And there's a couple of different microcontrollers that you can use with it that are designed to work with it. There's probably, oh yeah, you could use any microcontroller really, and just run wires from it to the baseboard somewhere, anywhere on the baseboard really, or into one of these wires if you happen to have that standard, or where is it, if you have the stem or grove standard on one of your microcontrollers, you can run it in that way. So this is a fun little system. As I said, probably pretty good for education, definitely good for prototyping and just tinkering around. And I think if I'm messing with I2C stuff, I'm probably going to reach for this first to do my experimenting and my setup and everything else on before I move on to making it more permanent or whatever. It just seems like a good system for prototyping and whatnot. Anyway, I hope you found that interesting, slightly informative, not too much of a sales pitch, because I didn't really intend it to be one, but it kind of sounds like it was. Anyway, I'll put links to the Universal Solder website down below. Oh, and one other thing. This is especially important at this time to my American viewers. All these modules are compliant, so they should be free from customs and tariffs as of the day I'm recording this. You know, anything could change in the future, but right now there is a section specifically on the Universal Solder website listing all of their products that should be tariff-free, and that includes all of these Canablocks modules. That said, thanks for watching. I do appreciate that. Questions and comments and links and whatnot all down below. Talk to you later.